Okay, to start, hello everyone, my name is Hafiz. Today I'll be talking about the procedural generation from prototyping to environment design. So to start off, let me introduce myself. I'm a technical artist currently working at Metronomic. I've been working there since December 2018. I started off as a 3D modeler for the environment, and then I became a tech artist in April 2023. And at the moment, I specialize mostly in shader authoring and also procedural generation. So a little bit about our company, Metronomic. We are a Malaysian company focused on producing original video game IP. And these are our founders, Daim, our creative director, and Wan Hazmi, our game director. And here are some of our team members. At the moment, we have 20 people working full-time and around 10 freelancers. It's John. All right, so our first game is called No Straight Roads. It's an action adventure game where you control indie rock duo trying to topple the EDM empire. And here's the trailer for our game. Right. So thank you. So that was our first game, our debut. And right now we are working on a new title called Onde Onde. It's a puzzle adventure game that's rich with Malaysian culture and family values. So here's the teaser of Onde Onde. Thanks. back to the original topic. So I would like to first preface by saying our new game. So I would like to preface by saying that so right now we are focusing more on like adventure game. Our previous title is actually more of a boss rush. So now a new adventure game usually involves a lot of level design. So my involvement in this is usually I need to create tools for the level designers and environment artists so that they can iterate through the process, creating prototypes, level blockouts, and such. So our development tools actually we use Unreal Engine 5 for all our titles, and we use heavily Unreal Engine's blueprint for gameplay implementations, for developing tools, and also for the procedural generation as well. And also we use Unreal Engine's procedural content generation plugin, which is actually a new plugin for technical artists to use to basically generate anything for your game procedurally. So the challenges that we currently or we had faced before this was that we want to have a very rapid iteration for prototyping. And to do this, how we use procedural generation is we use a single spline-based procedural tool. Um, and the next challenge is that we need to have rapid iteration even after prototyping. And to achieve this, we need to ensure that our environment workflow is non-destructive. Thirdly, we face a challenge where all the environment designs and the concept art need to occur concurrently for various circumstances because we need to get the ball rolling while the concept is actually being produced. So in order to facilitate this, we need to ensure that all our procedural tools are applicable later on for art direction purpose. And also performance. Usually for procedural generation, um, it goes without saying that all the optimization has already been handled um, inside the procedural tools, but we need to actually do some more tweaking because a lot of the optimization, especially if you are using Unreal Engine, the artists and the technical artists needs to work together to actually go through levels by levels and ensure that all the meshes are instanced. For example, um, all the mesh are called dynamically depending on the camera angle, etc., etc. So the procedural generation tool that we have actually automates this process. So our approach to building procedural tools, we need to ask ourselves. Um, so the things that we need to spot is like designers in building levels more than a single click button. So a lot of the misconception about procedural generation is that um, we have a tool, and then that tool, we click one button, and then everything will be generated. Level is done. We can ship the game. But that's not always the case, especially for video game, because um, level designers need to have creative freedom, environment artists as well. So a lot of the handcraftiness still need to be involved, even if we have a very, I would say, robust procedural tool. And also we need to balance between generic and bespoke solution. I will talk this more about the what's the difference, but I want to first let you know that the challenge that I had personally was that I tend to over-engineer stuff. I create tools that is too robust, too generic for like that can be used for anything, any biomes, any kinds of environment. So that was a mistake that I encountered. And also we need to make sure that our procedural generation are deterministic. And what this means is that for each iteration, all those are saved, and you can always cycle back and forth between those iterations. Because what if we want to like say you have encountered an iteration that is already the best so far, and then you want to see if there are any more iteration that's even better. So you cycle through again, and then you see nothing that's better. So you want to cycle back to that particular one that you have decided that is the best one. So which is why it's important for our tools to be deterministic. Also, we need to allow our procedural tools for artistic control, especially for a stylized environment. Okay, so coming back to the bespoke and generic solution. So bespoke solution, I'll talk about the generic one first. So generic one, what it means is that we have a one size fits all kind of solution. So a one tool that can generate everything. So I only have to implement one time the instructions for creating the environment or the level, and then the environment artist or the level designers will have to go through all the parameters, which can be a lot. Um, so it actually can be like a bit daunting for them. So which is why it's not always the best solution for building procedural tool, but it can still be used, especially if you want to whip up something very quickly inside the level, and then just pick some parameters and that's it. So all this is like very high level first, but I will get into detail a little bit more later. Generic tools are usually simple in terms of the script and fast to generate. In other words, it's more performant, and it can still execute both in runtime and in editor. And the outcome is dictated by how the user tweak the parameters. So the better solution, or I would say like the latest that we have utilized so far, is using a bespoke solution, which is we want to create, so for each biome, environment, or level, the implementation will be different each time. So we have a different PCG graph, different blueprint codes for each of those. And what this actually promotes is that we have better flexibility, and the parameters are minimal and very specific. For example, we have we have a biome for creating a forest, and the parameters will be something like the density of the trees, the lushness of the grass, um, the type of forest. Maybe you can have like a tropical forest, or we can have a more like a pine type forest. So those parameters are specific for that kind of biome. Whereas in the generic ones, it's something like population density, scale randomness, what else? The color variations, but the user need to like apply their own context to those parameters rather than, oh, it's intuitive. I know that I want to have a lush forest, so I just have to tweak the specific parameters. And the bespoke one, since it's actually very complex because we need to implement uniquely for each of those biomes, the execution for the bespoke procedural tool need to only occur in editor. And the outcome is dictated by the script, which is the technical artist. So the technical artist will have to write based on the logic of how does forest generate itself naturally. So the generic approach, what we have so far is these three tools: volume spawners, grid spawners, and spline spawners. So as the name suggests, they are basically just spawners. Technically not so procedural, but it does its job. It spawns the objects or the props based on the whether you're using volume or spline, spawn alongside of spline, things like that. And here's a demonstration of how we use a volume spawner inside our level. As you can see, it's deterministic. We cycle through back and forth to see which one is the better result. And whenever we move the object, the placements will try to stay the same because we want to control the composition even better. And it's conforming to the landscape. Now, what I'm trying to do here is that I'm trying to tweak the parameters. You see all this list of parameters is actually very, very overwhelming. So you need to know what you're doing basically as an end user. So my job, or rather that what ended up happening is that I'm the only one who actually used this tool rather than the level designers or the environment artists. Or even if they use, they really don't know like what are the options that they have while using this tool. So I'm actually adjusting the clumpings, the scale randomness to achieve that more stylized look. Yep. So that's our volume spawner. And then this is our spline spawner. Okay. Same thing. It conforms to the landscape. The only difference is that it spawns alongside a spline. And also the parameters are a bit too overwhelming. You see in the trailer before, those environment that we created inside the trailer are mostly generated by this tool. And what we need to do is just plug in all the static mesh assets, all the materials, and then it will just generate itself. Right. So we're using all those three tools. We have some issues, like I've mentioned. It's it takes time to actually iterate a level because all those are actually individual placements where if you have a large level, so you want to place each of the spawners in each area, and if the level changes, say for example, we want to move this particular section to another place, we have to actually carry all those spawners to that location. So it's not entirely iterative or versatile because we still need to do some adjustments. And also we have too many parameters to tweak. All right, so the meat of this talk is actually I want to talk more about how we use bespoke solution using the Unreal Engine's PCG framework, which is a plugin built inside Unreal Engine. It is a new plugin. At the moment, it's still in the alpha stage. So a lot of people, they are afraid to use this tool for Unreal Engine because it is alpha. But then again, if we only use this for editor purpose and it doesn't into your runtime build, then it shouldn't be a problem. Because when you ship into a build, the PCG will basically just disappear. And what remains is all the generated props that you have placed inside the level. Uh, how does PCG works? Here's an illustration of the PCG workflow pipeline. First of all, we start off with 3D modeling. Of course, we need 3D models. And then once we've modeled them, we kit bash into what we call assemblies, or what widely known as prefabs. And then these prefabs or assemblies will be harvested via our helper tool to create PCG point data. So PCG point data basically is an asset that encapsulates all the data of the assemblies. For example, you have the data for what static mesh is using. You have the data what's the relative position of that prop inside the assembly, etc., and what material it used. And then once we have harvest, we feed that data into a PCG graph, which is what you see here. And then we run some instructions to create some randomization. And then once we have created the graph, it will be encapsulated into an asset itself. And then we plug that PCG graph asset into the level vector. Then we press generate inside the level, and then it's done. So this is more simple this more simple implementation of how we use the PCG graph. So we have an input, which is the actor that we have placed into the level. We sample what is needed. For example, if it's a volume, that it will sample whatever that volume is intersecting. For example, it's intersecting a landscape, it will sample points on the landscape. Or if we have something like a spline that is attached to that actor, so the sampling will actually try to sample up the points alongside the spline. And then once the sampling is done, we do the randomization pass. And then lastly, we will output the result in the form of static mesh. that spawns into the level. Just a quick demonstration of how the PCG works, the end result. So we place the actor into the level, we have the PCG graph assigned, and now what we can do is just we modify the spline points to mold the shape of that PCG architecture. So here we have a platform, a basic one. We create the shape. And it's actually very flexible. You can mold it into any shape that you want. And then all the things that spawn, which is the floor, the trims, the fence, all will be procedurally generated. And just to let you know, hold on. What you see here is not actually an entire object. It's actually a combination of multiple objects that's combined into a whole infrastructure. For example, the floors is actually a combination of multiple planes that will try to conform within the shape. And then the walls is actually also a plane, or rather a two-sided plane that's placed alongside the spline. So it's not a procedural mesh, it's a procedural placement. Now I'm adding a building onto the platform. Also, I can adjust the shape of that building using the spline. Actually, should have used a time-lapse video because it's quite slow. Let's see. So you get the gist of it. So now I have the shape of the building. And as environment artists, usually what we want to do is that because it's a stylized environment, right? So usually the shape of the building or shape of the structure will always have this wonkiness. There's no straight lines. There's no, I would say, flat surface. Everything has objects on the walls. You notice there's a lot of skewness involved inside the structure. So you can tell it's actually you can have a lot of fun by using this tool. Just create whatever that you want. I fast forward lah. So, and then also we have the ramp or the stairs that is also part of the bespoke procedural method. So I need to actually apply the implementation of how we create stairs, how stairs works, and apply some sort of limitations because stairs usually don't slope more than 60 degrees, for example. So I need to make sure that I apply that limitation so that the level artists won't go beyond 60 degrees. Even the stairs, you can actually shape it into a, what shape is it called? It's a trapezium or triangle. And then we have another tool that generates bridge. And also we can mold and shape the bridge however we want. We want to make it curved, we want to make it slanted. We want to make it like a convex or concave shape. It's all up to you. Right. So the rest is just basically the same thing. And we also like have specific parameters to ensure that the level artists can decide whether they want to spawn buildings on the walls. So that's it. So why using PCG framework, which is the plugin, is the best approach for using this, the best tool for this approach or this solution. So the implementation for each biome is unique. And the PCG graph is actually quite easy to use. So even inside Metronomic, our environment artist who is not a technical artist use the PCG graph to create his own implementation. And it can be quickly churned out. So my job as a technical artist is that I don't really use the PCG graph. What I do or I involved in doing is I create multiple custom nodes or multiple function inside a library so that the artist can use them without thinking too much about how to achieve certain results. So a very generalized, a very specific functions that can achieve a reusable result is much more preferable. So that's why I come in, I create all these function libraries and custom nodes. So we use custom nodes to convert any repetitive operation for reusability. It's also for promote better clarity when we create the procedural graph. One thing that we actually try to promote in Metronomic is that all our workflow needs to be relatively clean so that a lot of people can be involved, and then one person can be done and the next person can actually work on the same thing, um, because the housekeeping work is actually very nice, and then having a custom node actually helps in doing that. The single PCG graph can have only like 3 or 5 nodes. So a forest, although it's actually sound complicated, we can only use 5 nodes to create a forest, and also to avoid spaghetti mess. So if you are familiar with node-based programming, usually if you have a lot of nodes connecting to each other, and then you have a spaghetti mess. And to do housekeeping for the node-based programming is usually like something like you want to arrange your room, right? So you move things here and there. Very different from code-based programming. Coming back to what I mentioned before, we have, oh, sorry, I haven't mentioned this. So we actually try to separate the PCG actor into 2 types, which is a local PCG and a global PCG. Local PCG is something that we want to create locally. I think the name is actually quite explanatory. The one that you have seen before, the building and the platforms are all local PCG that's contained within that same that particular area. And it generates a standardized level architecture, for example, like platforms, buildings, bridges, ramps, etc. And we have one local PCG for each architecture, for each of the biomes. And it's usually good for making the first pass of the environment. And to add more environment context, without the environment artists tweak it, the level designers also can be involved in creating the environment. And whereas the global PCG is actually one for each biome. And then how it's placed in the level is that once we have placed all the local PCG and everything is done, then we add a global PCG that encapsulates all the entire level. And then it will generate a more detailed environment based on how we placed the local PCG in the level. And it's a good second pass for the environment and good enough for level presentation. And what it does is that it actually adds more noise, uh, more detail, so that it will look nicer for global PCG. Excuse me. Just an example of our local PCG. We have platforms, which is the one that you've seen before. We have enclosure, building, bridge, and ramp. So far, these are only things that we need for each of our bio. We don't need more than this, because this is like the standard, I would say, architecture when you block out a level. So you don't need like, I don't know, some fancy new architecture types. This is good enough. So local PCG, what's good is that the palette are minimal, like I've shown you before. There are only 5 that we can use. It's good for communication also. So when level designer communicate with environment artists, they can just use this as their language. I want to use platform for this particular area. I want to use building. I want to use enclosure, things like that. So a local PCG, even though we have multiple PCG graph for each of the biome and each of the architecture, we only need one single actor container. Um, and then this actor container, by default, it generates the proxy environment, like you've seen here. So even if I haven't come up with the biomes or the PCG graph, I already have the proxy environment. So the level artist can just move on and create, prototype the level, iterate without having a bottleneck of waiting the environment to come up with the biomes. And once the blocker is done, once the environment setup is done, you can just plug in this PCG graph into the same actor, and it will just replace the environment just like that. Just a demonstration how the replacement or swapping works. I just replace the building, the platforms from the block out to the environment, and that's done. We don't need to tweak anything else. So the global PCG, like I mentioned, it generates environment for the entire level. We probably only need one because we don't want to have like over too much, I would say, too much going on for a particular biome. For example, a grassland, we only have like grass, ferns, rocks, etc. And we only need one PCG graph for that. And it adds additional noise to the environment, and it works well with the open landscapes. It's a demonstration how global PCG works. So you can see the environment is actually quite detailed. The grass are actually like, it's very detailed. And you don't have to hand paste all of this. Everything is just procedurally generated. And now what I'm trying to do is that I want to modify the road a bit. And once I've modified the road, I regenerate the environment, and everything will just updates. Try to so this process is actually very iterative. So usually level designers, they can't design something without environment context. So if we have environment context already placed, so they know how to design the level. So level designing is, I would say, it's not just block out, it's not just grids, it's not just primitive shapes. You need all this environmental information for you to perform effective level design. And here we have all the specific parameters for the biome. So like I've mentioned, bespoke solution involves a lot of very specific parameters, and it only have a few of those per PCG actor, as opposed to the volume spanner that we have seen before, which is abundant. So here we only need to focus. I don't know, you can see here, I'm actually adjusting the grass density, adjusting the grass height, whether I want to spawn the side props alongside the road, the density of the side props, etc., etc. How we prepare the assets for PCG? We need to actually brief our 3D modelers when we create the assets. It's not just we create an asset, we plug into a PCG graph, and it just works. We need to consider things like where the pivot is on the static mesh. What is the standard scale? Is it going to be a standard scale for the floor, 100 centimeters or 1,000 centimeters? Things like that. And this needs to be communicated throughout, and then have to be documented as a form of environment regulation on how we prepare the assets, so that it can be compatible with the PCG generation. Um, just what we call assemblies. So what I've mentioned before, assemblies like prefabs is a combination, it's a kit bashing of multiple props to create a larger environment. Uh, so it's important for us to make sure that each of those props are modular. And also, when creating assemblies, the environment artist can actually control the composition so that um, the because we want to create a stylized environment, right? So the environment artist can actually adjust the wonkiness manually per assemblies, uh, adding more context. For example, this is actually a house section. Yeah. So controlling the composition is actually important because of the stylized environment. So before we plug the assemblies into the PCG graph, we need to actually inform the PCG of what these props actually are. Because the PCG graph or the system do not recognize like what is the prop. So we have to manually put a tagging for each of these props. In Unreal Engine, each actor is actually has its own tagging system. So it's already built in. So what we do is that we add the tag for each of the prop, telling the system, okay, this is actually an icon, this is a window, this is a door. And then once that's done, um, it's basically telling the PCG, then I, as a technical artist, can decide what are how I want to randomize each of these individual props. For example, I want the icon to have like 20 degrees variation in terms of the rotation. So I have to filter the icon, apply the randomization, and then spawn the static mesh. And also we need to create multiple sections for the assemblies. For example, we have a bottom section of the building and a mid section of the building. And the PCG will detect whether if the points is actually on the floor, then it will generate the bottom section. If it's anywhere at the top, it will generate the mid section of the assembly. And we can actually add more sections, for example, the top section or the corner section, if we want to have more variation. Here's a demonstration of a building using the PCG and how the assemblies actually fit into the generation. Okay. Here we have specific parameters for the level design to adjust the number of floors, for example. And as you can see, even though all these are actually using the same assembly, which is the midsection, excuse me, but it still looks different because once you have plugged inside the PCG graph, I want to apply the randomization so that each of the assembly will still look different from each other. And now I just click next iteration to cycle through what are the results I want. So we we have all this great procedural tool, but then what if the artist or the level designer want to have further customization? So in which case here we have created a tool for creating holes, for example. So this is actually useful if you want to say create a door or an archway to go inside a building. So we just create a subtraction tool, a subtraction volume. We just apply the tag saying that this is a PCG actor and I want to subtract whatever that's intersecting with. So I just intersect with the building and we create the hole. And another one is called insert volume. So what it does is that I'm telling the PCG to replace the section into a more unique assembly. For example, here I want to replace this particular section into Watergate. And I apply the tag and it will just work like that. Yeah, so this is more relevant to the topic because we have multiple stages of level development. The first one is called blockout prototype, and you've seen before how we go about this is that we place the local PCG inside the level using a proxy environment. And then the second stage is applying the first environment pass. We do this by just swapping the PCG graph into the local PCG to add environment context. And the third stage is the second environment pass, where we add the global PCG to add additional environment noise and details. And lastly, polish, we actually use the generic procedural tools, which are the volume spawners, the spline spawners, to add more details. But this is usually in the polish stage, which is right towards the end of the development. So I want to actually talk more about determinism, because this is actually very important for procedural generation. I've mentioned before, each iteration must be deterministic, and each iteration can be safe and can be cycled back and forth. Important for artists, important for level designers, if they want to see the best and optimal result. So we have the procedural tools. Now we need to talk about like how we expose the parameters to the user so that it's easy to use and understandable. The parameters needs to be very minimal and only expose stuff that need to be tweaked for level design and artistic purpose. Whatever beyond that, you can always tweak within the graph itself. Here's the basic structure of the user parameters. So I haven't mentioned before, but how the PCG actually plays inside the level class is that we have an actor, which is for those who use Unreal Engine, you know it is actually an actor, the stuff that you actually place inside the level, and then we attach the PCG component, which is the thing that we shove inside the actor. So the actor itself, we expose the parameter that's relevant to the level design. Okay, almost done. So that the level artist can just close one eye, focus on the level design, no need to focus too much on the environment. And later on, the environment artist will touch the same actor, and they have to click the PCG component and adjust the parameters that's relevant to the environment. Example like decoration density, random hue range, wonkiness, etc. Right, so the presentation almost ends, but I want to depart with a personal note. We are still learning. All our approach and methods currently work for now. And lastly, my favorite, if you want to create a procedural tool, avoid over-engineering, because you can go into a rabbit hole, and what end up happening is that you waste too much time, and the end user will not be able to understand it, and end up you are the one who have to apply the procedural tools inside the level. So it's a dangerous thing to have. And thank you very much.
Thank you. So we have time for Q&A. If anyone wants to ask what happens over here,
Yeah, actually the question, so you asked whether the procedural tools can create LOD and dynamic culling, right? So that's the question. And the tool actually can do both. It's already built into the PCG framework plugin. You can just create the environment, and everything will be handled by the system. But as a tech artist, you still need to manually tweak those parameters that's relate to dynamic culling and the LOD. So LOD is actually static mesh specific. So each of the props has its own LOD. For example, a vase has its own LOD, a grass has its own LOD. So you need to tweak based on that props, depending on the type of game you're making. So if you're making a third-person game where the camera is actually quite far, you need to consider how does the mesh look from the horizon, right? So you need a multiple LODs for those particular prop. And then this is asset specific. Whereas dynamic culling, you can tweak using the PCG system. There's actually a very simple parameter called start distance and end distance. Start distance means that how far from the camera that you want to start to cull the object that's generated. So yeah. You can actually automate it. Unreal Engine supports automated LOD creation, but I would recommend that you actually, once you have generated those LOD, automatically you need to manually tweak it, because sometimes when everything is automated, your game might be very unique. Your game, for example, might be using a camera with FOV 30, because the default FOV would be 90. So if you use a camera that's applying FOV of 30, then things might actually look closer. So you need to tweak LODs to match that distance. Yeah, so you have to say, for example, LOD3, you need to apply a more, the distance will be even more when you apply when you start to transition to LOD3. So yeah, it depends on your game. You still need to tweak it, although it's automated. Okay. No, it's so the question is that does the PCG system, in the editor, it creates a volume, and then once you ship it, it will convert into static mesh? The answer is no. So when you ship it, all those individual props will still retain its individualness, meaning it's still an individual static mesh that's spawned. But the difference is that it's still very performant. It's not merging into a single static mesh. It's actually converting each individual mesh into instant static mesh, which is in rendering pipeline. If you have instant static mesh, meaning that you only have to render or draw call once for the particular object, instead of having like multiple draw calls for each of those props. So it's still very performant, and you can still merge it. So once you've generated the PCG architecture, towards the end, you can merge it, and then you create a single static mesh. But I wouldn't recommend it, because sometimes, because once you merge it, what ended up happening is that you have a single static mesh with, let's say, like 5 million triangles, right? So the dynamic culling will not happen for that single static mesh. So it's not really performant unless the details of your props is actually very low, then it's fine. Ah, so the question is that how it works with Nanite and micromeshing. Yeah, it works both in default static mesh and Nanite. Sorry, the question is that whether Nanite can suit into the PCG. Yes, definitely is, because in a way, Nanite or micro mesh is what basically is doing is that uh, it's a alternative form of LOD creation. So it's actually streaming in and out of all the triangles. So so if you use PCG, we can still apply that nanite mesh. But if you want to adjust the LOD for the nanite, for example, how does the triangle um, stream for that particular mesh, it still need to be tweaked inside the static mesh editor.
All the time we have for right, and this one because we're going into a break, 15 minutes, so please come back at 5:30.
Thank you.